Now, we've just been talking about how we calculate all this with a given sample size. But really what we want to do is back up and say, all right, how big does my sample need to be in order to have the confidence that I want? So remember, the more confident that you are, the higher the sample size that you need, because you want your margin of error to be smaller, right? All right. So we know if we call E our margin of error, we know that the margin of error is equal to the z-score with the margin of error divided by 2 multiplied by the population standard deviation divided by the square root of n. So if we just rearrange the formula to solve for n, where we're like, hey, how big does my sample size need to be? What does n need to be in order to get this desired margin of error that we're calling E? Then we can get that we need our z-score times the standard deviation divided by that desired margin of error, all of that squared to get rid of the square root. Now again, if we don't know the population standard deviation, we can replace it with a reasonable estimate, which we're calling that's that sigma with the little hat on it, the little, not really an arrow on top of it, but it's like a little hat. So let's go back to our same problem. So we have a 90% confidence interval. Suppose that Jared would like to constrain the margin of error to be within 2 miles per gallon, right? So we want our margin of error to be within just 2 miles per gallon. And we know based on the data that the lowest mile per gallon in the population is 76 and the highest is 118. So how large of a sample do we need in order to compute a 90% confidence interval? Well, we can estimate, since we don't know the sample standard deviation or the population standard deviation, we can first of all estimate it as the range divided by 4. Okay, and it's always the range divided by 4. So our range in this case is the car that gets the highest miles per gallon minus the lowest miles per gallon, which is 118 minus 76 divided by 4. So we are going to estimate our population standard deviation as 10.5. Now, if you remember back in the second video, I believe, when we calculated the sample standard deviation for our sample size of 25, we got 10.7 as our sample standard deviation. So this estimate of the population standard deviation seems pretty right on, right? So then we can calculate our sample size by plugging this in. So at a 90% confidence interval, remember our z-score is 1.645 because that's 5% in each tail, multiplied by our estimate of the population standard deviation of 10.5 divided by 2, which was our desired margin of error, 2 miles per gallon. All of that squared, we get 74.58. This is our sample size. Now you can't sample 0.58, so we have to round up to 75. You always want to round up. So we need a sample, Jared needs a sample of at least 75 cars to give him a more precise interval estimate of the mean. And by getting that, we should have the margin of error be within 2 miles per gallon. So again, the general rule of thumb is always the larger the sample size, the better. So if we're talking about a proportion instead of a mean, then we're going to use the formula just a little bit different, the one we use for the proportion there. So we're going to say our margin of error then is our z-score with alpha divided by 2 multiplied by the square root of the sample proportion times 1 minus the sample proportion divided by n. So if we're rearranging that to solve for n, we get a formula where we've got our z-score divided by our desired margin of error, all of that squared multiplied by p-bar times 1 minus p-bar. Now, the p-bar, remember, comes from the sample. We must use a reasonable estimate of the population proportion p. So if we don't know the population proportion, which again we rarely do, we'll use a sample. Maybe we've done lots of samples, and so we come up with a pretty good estimate of what that sample proportion should be. So again, if we're going back to our formula, we've got our 90% confidence interval. We don't want the margin of error to be greater than 10% or 0.1. How large of a sample do we need to be? And this is where we're looking for the proportion of cars that get over 100 miles per gallon. So remember, for our z-score of 0.05, it's 1.645. We've known that. We've looked that up in the table, and we've calculated it in Excel. So when we plug that into our formula here, where remember we're using a population proportion of 0.5 because that's kind of the a conservative estimate. So if we don't know what the population proportion is, we'll use an estimate of 0.5. And we get 67.65 as our desired sample size, which we would round up to 68. So we needed 75 for the sample mean to be within 2 miles per gallon, and we need a sample size of 68 to get our proportion to be within 10%.